Hi, it's Tom here from FDS, and today we're going to look at flywheel matching. Now, I've been asked by a few people about this, and I thought I'd go through the technique that I use to create match pairs of flywheels. Now, this is succinct from balancing. What we're not doing is we're not doing any dynamic balancing of the flywheel. What we're aiming to do is we're aiming to provide ourselves with matched pairs, and to do so we need to measure the weights and we need to measure the sizes, and then we need to get our flywheels and sort them into pairs. That will give you a definite bonus to your smooth running of your blaster. You'll waste less energy on vibration from your motors, and you'll get greater precision because your flywheels will be of similar weight and similar size, and therefore should have equal input on the dart as much as is possible in a flywheel system. And if you even out some of those discrepancies, obviously that's going to affect precision. Now, if you think about the flywheel speeds of our blasters, that's between 30 and 40,000 RPM no load speed, and around 26 to 28,000 load speed. That's quite a lot higher than things like car engines and motorcycle engines, and some components in those engines may get to those speeds, but generally speaking that's quite a lot higher than you would get in those mechanical systems. And yet in a performance engine every part is balanced, and also every part is matched, so you start off with good tolerances. So that's where we're going with this. We're starting off with good tolerances, and you can do gravity balancing on these components, but I don't have a gravity balancer that fits them at the moment. I had to borrow one last time I did it, and the guy is away at a race meeting this week, and he didn't have the balancer available. So I will do that in a separate video. It requires a bit of thought about how to film it as well, because you have to film that in the opposite direction. You can't film it from overhead. So we'll start with what you need. You'll need a marker pen of some description with a fine tip. You will need a set of reasonably precise scales. If they can go down to within, these ones go down to within 0.01 of a gram, which is more than enough. And then you will need a set of digital calipers. You can use a set of dial gauge vernier if you're more comfortable with that. I've got to thank the guys in the machine shop over at Datum Alloys for the loan of their calibrated set of digital calipers again. Now, I normally do these in batches, so I don't need to have calipers all the time. I just borrow a set when I need them. So you can see this is a mixed bag of flywheels. These have come from a Brit Nerfer super gripper who does a lot of flywheel replacements, and you can see that there are a couple of differences in some of these. And what you've got here is you've got a modulus pair, I think, the cream coloured ones, and then you've got a demolisher pair. You can see I've already weighed the demolisher pair because I built a demolisher for somebody. And then these light coloured ones here are like Strife Rapid Strike, Strife Rapid Red, all of those kinds of areas. You can see there's one narrow one there, I don't know where that's from. I can't remember what the beveled edge is from. That may be one that I put in the pile as I tidied up. So I've got 2, 4, 6, 8, 10 flywheels. I would suggest that the minimum number you need to do this effectively is going to be 4, because you're going to be able to get closer. The more flywheels you have, the more easy it's going to be to make match sets. So we're going to start with weights. So we can turn on the scales. So put the first flywheel on. Then write the weight on. 4.18. You can see these are very cheap scales. They don't always reset to 0 very well. Doesn't matter if you've got cheap scales and the calibration isn't great, because as long as you weigh all your flywheels on the same set of scales, all things being relative, you'll still be able to match the pairs. So next one. See, I'm writing the weights on so I remember. So I'll go through and I'll weigh the rest, and then we'll go on to the next stage. So there you go, I've weighed all of those flywheels, and the Strife and Rapid Strike ones change weights from 3.96 up to a high of about 4.18. And you'll see there's some here with some flywheel deposits still on them. That dart foam, you could take all that dart foam off, and then we'll see how much that affects the weight. So if I peel that off, so that was 3.06. Yeah, 4.005, 4.04, yeah, 4.05. So that was 0.01 of a gram for the dart residue. So that wasn't much. Right, those are done, and you can see there's quite a wide range. The next thing we need to do is we need to use the digital vernier, and we use these in the machine shop often. These are called a guessing stick by people who measure really, really small micro components, because they're not super accurate. They're down to about 0.005 or 0.01 of a millimetre. Now you can see this has a calibration certificate on the back, and these are done regularly in the machine shop to ensure that they stay true. So I know I'm pretty good on these. You turn them on, and then you gently push the calipers together, and you make sure that you've zeroed them. So those are zeroed, and then obviously as you slide the calipers up, you've got your measurements. So what we're going to do is we're going to measure the flywheels at 3 points across the circumference, and you're going to measure them like this because they are tapered. So you want to measure them. So there we go, 33.5, 33.53, 33.58. So it's quite difficult to get a really good 33.56. So there's a bit of a taper going on there, as you can see, top to bottom. They're 33.59 at the bottom and 33.46 at the top. So there's a taper of 0.1 of a millimetre across the face of this particular flywheel. And if we look at the average roughly in the centre there, 33.5. So I'll write 33.56 on that one. And then I'll go through and I'll measure the circumferences of all the other flywheels, and then we can go and start matching them into pairs. Now just a quick point on flywheel dimensions. If you look, here's a demolisher flywheel, so we'll get an average measurement off that demolisher flywheel in the middle. So I've decided to ignore the hundredths because what we're working at, the tolerances we're working at within the rest of the blaster, are really not going to be helping. Hundredths of a millimetre are not going to be an issue. So you've got 33.6 across there, still 33.6, and then they're quite deep. There's a greater depth to those. So those are 16.4, and if we look at a standard rapid strike flywheel, 33.3 millimetres across and 13.7 millimetres deep. And then these ones, go in the middle, 33.3 millimetres diameter, and then they're 13.9 thick, and those are the modulus ones. So there is a little bit of difference, so it's worth measuring all the axes. I'm just going to measure the middles because we're only worried about diameters in this direction, and then obviously they'll pair up with weights. So finish off. So there you have it. There are some matched sets of flywheels, and obviously flywheel matching has gains in loss of vibration, and you're reducing wasted energy in the system because the motors are transferring their energy much more smoothly between the flywheel and the dart. So you should get a corresponding improvement in precision. I struggle to say accuracy. This is 50 caliber Nerf darts we're talking about. Accuracy and Nerf darts are slightly mutually exclusive in some respects, especially full length, and you can't use flywheels with Stefan darts. So you have to take these small gains where you can get them, and the FPS gain for this is between 3 and 5 FPS average, measured on a 180 flywheel blaster, and I've got the figures for that knocking around somewhere. I'll see if I can find them to add to the video, but if not, then you'll have to trust me. And I've actually seen other people that I've sent these to. I've done a couple of sets now. Nearly everything I made since December last year has been done this way, and most people have reported much higher levels of precision with flywheels made this way.